The simplex method, applied to a linear programming problem, involves a lot of arithmetic manipulation, which means it's very easy to make numerical mistakes, especially in an exam. One way of reducing this potential for error is to make use of the matrix manipulation facilities that exist on many calculators. Let's see how to do that using a simple example. I'll use the Casio FX CG50 calculator here, but you could use any calculator with the appropriate matrix manipulation capabilities, though the keystrokes might be different. Here is the example question. Solve the following linear programming problem using the simplex method. Maximize p equals 2x minus 3y plus 5z, subject to the three constraints shown here. Because all three are expressed in terms of less than or equals to conditions, we rewrite them as equalities by making use of three slack variables. We turn the constraints into equalities using slack variables s1, s2 and s3, where I've labelled the constraint equations as c1, c2 and c3. We also rearrange the objective function like so. Now we can construct the tableau, or table of coefficients. There is no universally accepted method of displaying or labelling the tableau. I've chosen to put the objective function coefficients as the last row. You might come across it displayed as the first row. I've also labelled the constraint rows as C1, C2 and C3. Again, you might find them labelled differently. Regardless of how it's displayed, our first task is to identify the most negative number in the objective function row. Here, that is -5. This means that column Z is the first pivot column. To identify the pivot row, we form ratios by taking the numbers in each value column and dividing them by the corresponding numbers in the pivot column. The row with the smallest positive ratio is the pivot row. In general, we might possibly use the calculator to determine these ratios. However, for this example that's overkill, as we can see without doing any calculations at all that there can be only one positive ratio, namely that for row 1. 44 divided by 2 is positive, 44 divided by -1 is negative, and 44 divided by -4 is negative. The intersection of the pivot column and pivot row gives us our first pivot position, here occupied by the number 2. We now need to use standard row operations to change the pivot value to unity and the other entries in the pivot column to 0. To do this, we'll take advantage of the calculator facilities. We first enter the numerical values as a matrix in the calculator before starting all the arithmetic manipulations that need to be done. We will need a matrix with 4 rows and 7 columns. On the CG50, we select the Run Matrix mode. In the Run Matrix mode, we select the Matrix Vector option. Select a matrix. I'll use matrix A here. Press the Execute key to bring up the Matrix Dimension menu. Enter 4 for the number of rows M and 7 for the number of columns N. Pressing the Execute key again, we get a matrix of size 4 by 7 with zeros everywhere. The matrix is too large to display in its entirety, but we can move around it using the cursor control keys. Now we need to overwrite the zeros with the numbers from our table. Having done this, we return to the pivot position in row 1, column 3, and we're ready to start manipulating the matrix values. We need to perform a number of row operations, so we select the Row Op option. We want our pivot value to be 1, so we must multiply all of row 1 by a half. Select the Multiply Row option. Enter 0.5 for the multiplier k and 1 for the row m. Press the execute key to complete the operation, and we can see that the values in row 1 have all been halved. Now we must make the other entries in the pivot column become 0. To do this for row 2, we simply add row 1 to row 2 and replace row 2 with the result. So select the row add option. Enter 1 for row m and 2 for row n. Executing this, we can see that row 2 has been modified with a 0 in column 3. For row 3, we need to multiply row 1 by 4, add this to row 3, and replace row 3 with the result. So we select multiply row plus. We enter 4 for the multiplier k, 1 for row 1, and 3 for row n. The row 3 entries have now been modified with a 0 in column 3. We repeat this for row 4, but with a 5 for the multiplier k, 1 for row m, and 4 for row n. Now all the rows have been modified, and we can transcribe the resulting matrix values from the calculator to paper. The next step is to identify another pivot value. We can see that the most negative value in the objective function row is -2. So this makes the y column the next pivot column. To identify the next pivot row, divide the numbers in the value column by those in the pivot column and look for the smallest positive result. As before, in this case it's clear that there is only one positive ratio, that for row 2, so the new pivot position is at the intersection of row 2 and the y column. As the new pivot number is already 1, we don't need to replace row 2 with anything, but we do need to zero the other entries in the y column. To zero the row 1 entry, we simply add row 2 to row 1 and replace row 1 with the result. Choose row add. Enter 2 for row m and 1 for row n. To zero the row 3 value, we need to multiply row 2 by 3, add to row 3, and replace row 3 with the result. Choose the multiply row add option. Enter 3 for the multiplier k, 2 for the row m, and 3 for row n. Repeat this process for row 4, entering 2 for k, 2 for m, and 4 for n. Now we again transcribe the numbers from the calculator to paper. There are now no negative values in the objective function row, so we don't need to do any more matrix manipulations. We can immediately see that the maximum value of the objective function p is 242. To find the values of the corresponding variables, we first need to identify those columns that have a 1 in one row and zeros in the other rows. We already know that the y and z columns are like this, but we can also see that the S3 column is like this. Looking at the value column, in the rows that correspond to these ones, we find that y is 66, Z is 88, and S3 is 330. The other variables x, S1 and S2 must all be set to 0. You should of course satisfy yourself that the values of these variables are consistent with the value obtained for P and with the 3 original constraints. It's still possible for mistakes to be made, of course, but I hope you can see that the calculator should minimize the possibility of those mistakes. For those with a Casio FX-CG50 calculator and some other Casio calculators, here is a list of the keystrokes used in doing the calculator calculations.